Hey everyone, and welcome back to the Sawickipedia. Today we're going to show you a simple way of creating a Commodore 64 video output cable using some fairly inexpensive parts. So for this I actually picked up a SCART cable that already had an S-video, composite video and stereo audio outputs. All I'm going to do is lop off the SCART connector and replace it with a DIN connector. Now there are a few options here. You can chop off these ends to replace that with a DIN connector so that you'll have DIN on one side and obviously keep the SCART connector on the other side if your TV's got a SCART input. A VGA connector that I also picked up quite cheap for about $5 that had a VGA male connector on one end and all these 4 connectors in a female version on the other, so you could potentially wire up a DIN connector by chopping off that VGA and have yourself female connectors so you can use your own audio and video cables. But unfortunately that thing didn't arrive in time and it's not going to matter too much for the purpose of this video. So yeah, I'll show you how to wire one of these up and also the easiest way I've found to solder them, because they are quite painful to try and solder. So what you'll need for this is obviously a donor cable that has either the SCART connector or the VGA one that I spoke about. And yeah, the other thing you'll need is a solderable DIN connector. If you do pick up the one with the 8 pins in a round shape, I'll show you how to remove those extra 2 pins that aren't needed. Otherwise, if you manage to find one in the proper U shape for the Commodore, you don't have to remove those pins, but at the same time, they're still not needed for what we're going to be doing today. The other thing you'll need is preferably a 330 ohm resistor. This is for the S-video output, just to lower the actual voltage on the chroma line, because the Commodore 64 predates S-video standards. So it actually puts out too big a signal on the chroma line, so there's too much color information, and you usually end up with a checkerboard pattern on modern TVs. So this pretty much cuts that out. I mean, I found anything from 200 ohms up to about 1 kilo ohm does the same job, but something around 330 is generally accepted as the best option for most TVs. Some flux paste will come in handy. Obviously, some soldering iron, and wire cutters, wire strippers, and preferably like a little pair of side nippers like this. And a multimeter to test your connections when you're finished. And last but not least, just a little bit of heat shrink. You don't need too much. It's just enough to sort of cover up one end of that resistor. So maybe a centimeter of heat shrink in a diameter similar to, or slightly bigger than whatever resistor you're using. So you'll have to excuse the noise, it's quite windy today. So the first thing we're going to do is just cut off the end that we don't need from our cable. In this case, I'm cutting off the SCART connector. Obviously if you want to have the SCART connector still on, cut off the other end. Or if you've got the VGA cable with the sockets, obviously cut the VGA connector off. I'll put that aside for a sec. Let's just prep the plug itself. So remove the jacket and these bits. Now with this one, it is an 8-pin sort of round-shaped DIN connector. Obviously if you've got the U-shaped connector, which is the correct one for the Commodore 64, you don't really have to modify anything, but if you've got one that's the round shape, there's a simple way to remove the unwanted pins. Just sort of clamp it on here, and then just use your soldering iron just to push those pins through while heating them up at the same time. There's one. And there's the other. Now obviously they will be very hot. Get rid of them. Alright, and now we've got a plug that's going to fit in the Commodore 64. And I'm also going to apply some flux. This particular one is like a paste, but obviously you can use a liquid flux if you've got that. Just use my finger to get it around. No, we'll use one of the old pins just to really get it all in there. Okay, finally, I'm going to get a bit of solder that's just the correct width to fit in the back of the actual pins. If you've got the scooped out pins, it's a little bit easier to solder to, but if you've got the ones with the little hollow backs, it is still possible. But you do need to, either way you need to cut up a little bit of solder just to sit in the back of each pin. And the solder itself should sit almost flush with the top of the pin, so it's only a tiny bit in each. Okay, and then we're just going to melt the solder that we've placed inside the pins. So what you should end up with is a nice bit of solder in each pin, and hopefully none hanging over the edges of the pins. So now that the plug's prepped, we'll prep the cable itself. We'll strip back about that much. Now this stuff can just be cut off. It's just like a, it's almost like cotton. Get rid of that. And then we'll just strip back the individual wires. Now with these, it's a 2-core wire, so it's got ground wire over the outside, and the actual signal cable in the core. So I want to get plenty of ground wire to play with. Just move that all back out of the way for now. Now for the actual signal cables, on this particular one, red cable is our luminance and the white cable is the chroma. Yes, so we want to insert our 330 ohm resistor on the chroma side. So it's going to sit something like that. So I need to strip this back more than the rest of them. And these wire strippers are terrible for this kind of stuff, but it's all I have right now. And we just want to measure up roughly where we can stick that resistor, where we're still going to have room for it to line up with the approximate length of the rest of the cables, without going so far back that we risk interfering with the ground wire. I really do need some better wire strippers. Okay, so what I'm going to do is just tin this, so just a bit of fresh solder. All we want is just for the solder to cover the actual wire itself without sort of bulking it up. And then we're going to take our little helping hands And what I want to do is add this resistor in so there's just enough room for the resistor to connect to one side, and then I'll cut off the excess and we'll have the other resistor leg sticking out on the other side. It can be tricky to get these things to sit at a point that you want to solder them to. Hopefully that'll do it. And just trim off any excess lead. So there we have our resistor attached to the chroma line. The next thing I want to do is just get a little bit of heat shrink. I'll just have to cut it back to where that resistor finishes, which is back here. All I want to do is just pretty much cover up that resistor and the connection that's further back, just so we don't risk it getting in the way of the ground wire. Okay, so now that that's in place, we'll strip back the rest of the wires. Actually, before I do that, and it's always something that I manage to do, put the jacket on the cable before you go any further. That's not going to fit. I'm going to have to cut this down. It's sort of slims out the closer you get to the end of it, so just cut a little bit off. Right, finally, so yeah, that's a real tight fit there. Let's just bring these back into alignment. Okay, so we'll strip off the rest of these. Yeah, put the jacket on before you go stripping anything. Okay, so the red and white for the audio cables can be tied together. And yeah, we want to get them to a nice fine point, but only about 1 millimeter in length. That should do it. Just tin that. And it's just that little bit too long, so I just cut off just a tiny bit. And likewise, the composite video. And is also that little bit too long. These guys. Alright, so that really is like the tiniest amount of wire coming off them. Don't worry too much about the ground wire at the moment. We will deal with that at the end. We just want to get the fiddly stuff out of the way first. Just tin that too. Alright, so what you should end up with is some very short but pre-tinned wires with your 330 ohm resistor in the chroma line, your luminance, composite video, and left and right audio wired together, all pre-tinned, and the ground wire will all go together, but we'll do that at the end once we solder these individuals. And I'm going to start from this side. So this is pin 3 on the plug, which is our audio output. So we'll start by soldering the audio wires into the back of the plug. Alright, so that's the first one down. That's our audio connected, and you can see there is only just enough cable to go into the back of that without leaving too much exposed. So that's pin 3. Keep in mind what I'm doing here. As I solder these, actually connect this clamp to whichever pin I'm soldering. That just helps wick away the heat from the actual connector itself, so you don't end up accidentally pushing one of the pins through or bending it out of position. So we'll skip pin 5 for the moment. That's the audio input for the SID chip. And we'll also skip pin 2, which is the ground, or common ground for everything. And we'll go all the way around to pin 4, which is the input for the composite video. So next we'll move around to pin 1, which is the luminance signal, which in this case is our red wire on the S-video cable. That's better. So as you can see, there's very little wire coming out the end of each connector. And that'll become very important in a minute once we connect the ground up. I'll explain why we want so little wire sticking out. Last one to do is our chrominance or chroma, which is the middle pin, which has our resistor already attached. So now we've got all of our signal cables attached. The last thing to do is to wire up ground, which is pin 2 right at the bottom. Now this can be a bit tricky. As you can see, there's a lot of ground wires sticking out everywhere, and we need to try and connect all of these to a single pin and try and get all the ground wires facing the direction of pin 2, and then I'm gonna twist that into a big lump. So that's all the ground wires connected together. Now obviously this thing is massive and we want to connect it to a tiny little pin right here. So I'm actually going to use a bit of the lead that I chopped off the resistor. This is going to stick in the back of the pin and also just in through part of all these wires. So now we've got all of the ground wires going to that single point, which is the old leg of the resistor, and all that's left to do is cut that back to length so it'll fit in the back of the pin. Before I try and solder that, we'll just pre-tin this little leg. Connect our clamp to pin 2. That's the tricky part because obviously it's just exposed wire, so it will get very hot. Alright, so the ground is soldered together into the back of that pin. So that's pretty much everything connected. Now, the reason I wanted to have these wires so short is because we don't want anything shorting out to that ground wire. This is especially important if you're going to have the audio in for the SID chip grounded, which people say can help to basically dampen any interference on the SID chip, which I'll look at in a future video. We'll do some in-depth comparisons to having the audio grounded and not grounded, and also compare that with different SID chips and different board revisions, just to see what the difference is and whether there's a bigger difference between individual boards and different SID chips. So I'm going to ground pin 5 to pin 2, which is the SID audio in, to the ground pin. And yeah, obviously make sure that there's no chance of any other pin connecting to either that ground pin or the SID audio in pin, because they'll both be connected internally together. You don't want to fry a SID chip by accidentally having, say, the video touching the ground pin or any of this ground wire back here. So yeah, make sure you've got everything neat and tidy. So the way I'm going to ground the audio input is just use a bit more of a resistor leg, and it's going to be inserted into the back of that pin, and then it's just going to loop around the other one around the ground wire. And just keep in mind that when you're soldering this bit on, don't keep the heat on it too long, because otherwise you'll end up unsoldering the ground pin that you've already connected. And then we're just going to bend this little bit of wire, trim it back, and that's going to go into the back of pin 5, which is the SID audio in. And there we have it. So starting from this side, we've got the audio left and right, which is pin 3, the SID audio input, which is now grounded. So pin 5 is grounded to pin 2. Obviously we've got the ground connected, and moving around we've got pin 4, which is the composite video out, pin 1, which is the luminance on the S video, and in the middle pin 6, which is the chroma with our 330 ohm resistor in between. So I'm gonna try and neaten this up a little bit, and we'll stick the connector back over and just do a quick test to make sure we haven't crossed any wires. Okay, so last thing we want to do is just make sure that all the pins are connected properly. So we'll start with the middle pin, which is our chroma, which should have our 330 ohm resistor, and that connects to the top right pin on the S video connector, and we're getting about 330 ohms, so that looks good. While we're still here, I'll just make sure it's not connected to any of the other pins. There's a bit of resistance flowing through my hands, but no, that looks good. So let's just check the luma, which is now going to be this pin over here, and that should be connected to the top right pin, which it is, and it's not connected to anything else. We'll check the ground, which will actually probably be also on the case of the connector, but that's fine. As long as the ground isn't connected anywhere else, it's not a problem. The composite video, which will be this pin second from the right. That sounds good. And once again, make sure ground isn't connected anywhere it shouldn't be. Obviously those two pins have ground on them, and also the outside of the case has ground, but that looks fine. And then finally the audio, which should be the pin on the far left. Try and make decent contact. These plugs need a bit of a clean. This was a second-hand cable, so I'm not surprised that they're not very good, but as long as that's not connected anywhere it shouldn't be, and once again, ground is only connected on the ground pins, and obviously the outside of the jacket. So that all looks good. It looks safe to hook up to our Commodore 64. We're not going to kill the SID chip or anything by connecting something to the audio input that shouldn't be on that line. And yeah, that's it. You have yourself a Commodore 64 DIN video connector to S video, dual mono audio, and also composite video. Like I said, you can substitute this end with a SCART connector if you wanted to. So you'd have Commodore 64 to SCART. Otherwise, yeah, the VGA plug, which unfortunately didn't arrive in time, but you could always have Commodore 64, chop off the VGA connector, and on the other end you'd have sockets instead of plugs. So you'd have S-video socket and obviously audio and composite video sockets. So you could potentially hook up your own S-video cable of your choice, and obviously the composite and audio cables of your choice, so you can run them over a lot longer length if you wanted to. This cable here is about, I think, 1.5 or 2 meters long. You can chop off this little bit so that you can actually separate the audio connectors, and you know, potentially have audio going to a stereo or speaker system, and then either one of your videos, preferably this one, but if you're stuck using composite, anything is still better than RF. I mean, if you are still using RF, definitely give yourself an uppercut and get yourself a composite or S-video connector. So that is it. Now we've got ourselves a very cheap and very functional Commodore 64 video and audio connector with the option of S-video or composite video, and dual mono out, which will be good for when you're hooking it up to a stereo. And yeah, like I said, if you've gone the other option, you can have a SCART connector, or even 3-socketed or 4-socketed connectors if you include the S-video connector. All of these were done for about $5 plus $2 for the actual DIN plug. I do recommend picking up a couple of these if you're going to be doing this, because if you haven't soldered these before, they are incredibly hard to do. So it's always worth having 1 or 2 spare in case you stuff up a couple. And coming up, we'll have a look at further improving the video output. I recently received the LumaFix 64 board, so I'll have a play around with that. And we'll also compare different VIC chips and boards for video output and also audio output. And yeah, like I said, the difference between bridging the audio in for the SID chip with ground and yeah, having it not bridged. So yeah, definitely stick around if you're interested in those things. But until next time, thanks for watching this Wikipedia. Be sure to leave me any comments down below. I'm always happy to read them. And if you enjoyed this, give me a thumbs up. Don't forget to subscribe if you haven't already, and we'll see you next time. Cheers.